Solutions and moles. In this short video you should learn how to find the number of moles of a substance if you are given the concentration of the solution and the volume of the solution. And the equation you'll see on this screen. Let's consider a solution of sodium hydrogen carbonate, otherwise known as sodium bicarbonate or bicarbonate of soda. Let's take a look at a typical lab question you might see. Measure 50 milliliters of the 0.030 molar, capital M, sodium bicarbonate solution using the graduated cylinder and add it to the flask. Calculate the number of moles at this volume. Now the capital M, usually put in italics, refers to the molarity or concentration of the solution. That's one way, and a very common way, of showing the concentration of a solution, how much solute is in the solution. It means here in every milliliter of the solution there are 0.030 millimoles of the sodium hydrogen carbonate. So let's calculate from that to find how many millimoles are in 50.0 milliliters of the 0.030 molar sodium hydrogen carbonate solution. Now the definition of molarity using millimoles is millimoles of solute divided by the milliliters of solution that contain those millimoles of solute. Therefore, if you multiply both sides by milliliters of solution, you get millimoles of solute equal to the molarity times the number of milliliters. Now the molarity is usually written right on the bottle of the solution. So all you have to do is read that and then decide how much you are going to deliver in terms of milliliters. So the millimoles of sodium hydrogen carbonate given in the problem would be equal to the molarity, 0.030 molar, which we're expressing as millimoles per milliliter, times the volume, 50.0 milliliters, which we bring down from the problem. And when you do that calculation, you see that there's 1.5 millimoles of sodium hydrogen carbonate in the 50 milliliters of 0.030 molar solution. So to generalize, in this example the solution is 0.030 molar, or 0.030 molar spelled out. This means in every milliliter there are 0.030 millimoles of the solute. It also means in every liter there are 0.030 moles. If you have a larger quantity, sometimes you'll be working in moles and not millimoles. But in high school laboratories particularly, you rarely have enough material for a whole mole. The capital M can mean millimoles of solute per milliliters of solution. The capital M could also mean, and does also mean, moles of solute per liter of solution. To find the number of millimoles or moles in a given volume, you would multiply the molarity times the volume. If the volume is given in milliliters, then you end up with millimoles. If it's given in liters, you will end up with moles. Here's another example. How many millimoles of acetic acid are in 1.0 milliliters of vinegar? That is 2.5% acetic acid by mass. And then what is the molarity? Well, acetic acid is CH3COOH, or CH3CO2H. So first we need to find the molar mass. Well, the two carbons are 24 grams per mole, 2 oxygens 32 grams per mole, and 4 hydrogens are 4 grams per mole. When we add those up, we get 60 grams per mole for the molar mass of acetic acid. Now 2.5% vinegar is a way of saying there's 2.5 grams of acetic acid per each 100 grams of solution. Let's go on with the molarity of the vinegar. 2.5% vinegar. Let's figure out what the molarity is. Well, the millimoles in 2.5 grams would be 2.5 grams times 1,000 milligrams per gram times the reciprocal of the molar mass. There's 1 millimole in 60 milligrams. We just calculated that on the previous slide. That's 42 millimoles in 2.5 grams of acetic acid. Well, we have that 42 millimoles in every 100 milliliters of solution because the density of vinegar is really close to 1, just like water. So 42 millimoles in 100 milliliters is 0.42 molar. So each milliliter of vinegar has 0.42 millimoles of acetic acid. Now let's use the 0.42 molar acid to deliver acetic acid. And suppose we delivered 5 milliliters of that molarity into a flask. How many millimoles have we delivered? Millimoles equals molarity times volume. Well, the molarity is 0.42 millimoles per 1 milliliter, 0.42 molar. We multiply that by 5.0 milliliters, and we get 2.1 millimoles. Notice, when we use molarity in calculations, we will write out, either fully or in abbreviation, millimoles over milliliters. Do not use just a capital M, because that really doesn't cancel out like milliliters and milliliters do. So you've made, in this just 7 minutes, an important start in your journey to understanding solutions, concentrations, and the calculations of solution stoichiometry. You need to keep practicing this over the months so that you can get good at. Remember the definition of molarity: millimoles divided by milliliters.